All right, today I want to show you a demonstration of how you can modulate an electromagnetic wave in such a way that it carries information. And so I've got this demo set up here. I need to explain some of the parts of it first before we get into the whole demo. So the first thing I'll talk about is this thing right here. This is a solar panel. We've all heard of that. We know that solar panels take light energy from the sun typically and converts it into electrical energy. Basically, a solar panel is got a layer of semiconducting material, silicon chips, and photons of light, particles of light, each with their own a certain amount of energy. As those photons strike that panel, the energy of the photon is absorbed by the semiconducting material, and that is enough energy to boost an electron to a higher energy state, which then allows it to be conducted. In other words, it creates a current. So a solar panel takes light energy and converts it into electrical energy. And then, of course, my solar panel in this case is connected to my speaker, which we've seen before in another video. We know that the speaker takes electrical energy and converts it into sound energy. So all kinds of energy conversions happening, and that's really what happens in much of our lives anyway. Let me demonstrate it first. Right now, my workshop, I've got the lights on, and they're very bright lights. But let me show you, and I'll show you also why I have to do the demonstration in a darkened situation. Otherwise, these lights will interfere badly. So what I'm going to do is I'm going to turn on the speaker. I'm going to, first of all, turn this just so you can see, so it's facing up, facing the lights. And I'm going to turn on the speaker. Now that buzzing you hear is actually sound being created by the current. Now watch what happens. See, my hand is opaque to the light, so none of the light is reaching the solar panel. All right, so you see how that works. All right. So before I do the demo, I'll turn the lights off so we don't have that buzzing. What I'm going to show you today is a pretty cool demo. I have here a little apparatus that I built a couple years ago. I've got a 9-volt battery, and wires are running around in both directions, and they're running around to right here where I have, you can see it there, I have an LED, a light emitting diode. So those are the more popular lights today. And so the battery, of course, powers the light. You can't see it probably right now, but the light is coming on. But the battery just sends a constant signal. All right. So even if it made a sound, it wouldn't, I don't know, even have any, we wouldn't have a frequency to it because it wouldn't vary at all. It'd be continuous. So I don't even think it makes a sound by itself. But what I'm going to do along with that is I'm going to add another current right on top of it. So I'm going to put two currents together here. Now the other current is going to come from my iPod. Okay, so coming out of the speaker, so I've got obviously wires coming out of the speaker or earphone jack, and those wires, and so when I turn this on, of course, the iPod is going to produce music. It's going to send a signal. Now that signal is going to be attached here and here, and those two, so now there's going to be two currents going to the LED. One of them is a continuous current, and that's a lot of current from the battery. The other will be a weaker current from the iPod. Those two currents will add together, though, modifying the battery current. So that's an example of a modulation. Now that's going to cause the LED to flicker. Now it's going to flicker so much faster than we could ever see it. So if we were to look at the light, we wouldn't be able to tell a thing. That's things that are changing at all. But the solar panel is another story. The solar panel is going to be picking up that flickering light. It means, so when the signal is strong, there's going to be a strong current, and when the signal weakens, it's going to be a weak current or no current, and that's going to send a signal to the speaker that's going to be in sync with the signal coming from the iPod. So I'm going to pause for a moment and go turn off the lights, and then I'll run the demo. All right, and we're back. And see, I've turned the lights off. I've also turned on the speaker, and I've turned on the battery, and you can see that there's a light coming from the LED and the light shining on the solar panel, but you're not hearing anything because I haven't turned the iPod on. So like I said, the carrier signal isn't creating a sound at all. It just has no information in it. There's no variation whatsoever in its signal, so there's no information. So let me turn on the iPod. All right. You know I like my 80s music. That's REO Speedwagon, Roll with the Changes. I used to play that every day before a ball game in college to get me psyched up. Well, also while we got this on, let's talk about transparency and opaque again. So here's a piece of wood, and since that's opaque to the light, none of it gets through. It completely blocks the signal. Now you notice it's a red LED. So here's a piece of red glass. Now we're going to learn, we see this as red because it lets red light through. It actually blocks blue and green. So let's see. Maybe a little weakening of the signal. And it's actually still very clear. Transparent, the light that gets through cleanly without distortion. Okay. Now, here's some green glass. And I can barely hear the sound. Maybe you can too. But that is blocking most of the light. Well, it's blocking most of the red light. Okay. It allows green through. So if I had a green LED, I should still hear the music. And finally, here's a blue glass. And again, it blocks a lot of the light. It's pretty much opaque to red light, but it is transparent to blue light. All right, so I hope you enjoyed that. They say, well, where does that apply? Well, we've all heard of fiber optics. And basically, if you have cable, TV, this is how the signal is sent to you. The signal is sent via light. And instead of trusting that the light would make it through the air, which quite frankly, it wouldn't get blocked, they send the light through these plastic cables that it just stays inside the cables. It bounces through at the speed of light, but the information is being carried in the light, just like this demo was here. So fiber optics is using light and modulating it in such a way as you saw here, probably by putting a signal on top of a signal. There's a carrier signal, and then there's a source of light, and then there modifications are made to that by some source from the TV station, satellite station, that kind of thing.